Hello, everybody. Today we're going to be talking about what you probably thought we were going to be doing in stats for like the first 6 weeks, and instead we're going to do it in a day. And that's the measures of central tendency. And we're going to go over today, the stuff we're going to go over, this is going to be this entire unit. But in this video, we're going to do measures of central tendency. We're going to do that. So we'll do this. We'll talk about what an IQR is, and we'll use that to identify outliers. And we'll construct a box plot using the 5-number summary. And we'll go through all of this pretty quick because some of this stuff you've done previously in Algebra 2 and Algebra 1. So let's get right into it. First thing I need to do is I need to make sure we all understand what the difference between a parameter and a statistic is. This is a very, very big deal. We use the term statistics thrown around a lot, but in reality, we're going to be dealing with both of these. A parameter is something, a fixed value about a population. And a statistic is a value calculated from a sample. And the difference between a population and a sample we went over already. But once again, it's a very big deal. We need to make sure we understand what the difference is between these. So population is every single person, every single population, where a sample is just a small subset of the population. We will usually choose a random sample, but not always. And we'll talk about that more as the year goes on. So there are the 3 main measures of central tendency are mean, median, and mode. And mean is just the average. Median is the middle number. We'll go over this as the slides go, as we go further through the video. And mode is just the most common. Now, here's the tricky part, is when we talk about mean or average, sometimes when we talk about mean, we're talking about a population mean, and sometimes we're talking about a sample mean. If they say the average SAT score, they're talking about the average of every single person that took the SAT. On the other hand, if they say the average size of a killer whale in the North Atlantic, they didn't go out and measure every single killer whale. Right? Or if they say the average size of some fish in Lake Michigan, they didn't drain Lake Michigan and measure all the fish. And so we need to understand if we're asking about a population or a sample. So, did I go in too far? First one we'll do is actually median. Median's easy. You take all the data set, all the numbers in your data set, and you line them up, and you find the middle number. And it's going to be the 50th percentile. And we'll talk about percentiles in the next unit a little bit, in Unit 2. So we put them in numerical order. If there are odd numbers, right, so if it's like 1, 3, 5, 7, 9, 30, and 42, then this is the median, that's the middle number. But if I add another number, then the median is the sum of those 2 numbers divided by 2, or the average of them. So now the median is 8. Now, I have been talking about the difference between the mean of a population and the mean of a statistic. I know everybody just freaked out because this wrote on the screen, but this is the Greek alphabet, and we're going to use this a lot in this class. And some of the stuff you've probably already seen, this Greek letter should look vaguely familiar to anybody who took geometry or is currently in trig. But we will be using this Greek letter, mu, a lot. We'll also be using this and this, both the uppercase and the lowercase sigma, a fair amount in this class. This one you should also have seen if you take physics, that's delta. You'll also see alpha used. We'll use alpha a bunch in this class. For the rest of these, if you want to learn them, you can. Then you can go join a fraternity or a sorority. All right, so the mean. This is the formula for mean. And you can see we already got a bunch of Greek letters here. We got that sigma. Here's the mu. We got them. And so let's explain what those are. Oops, sorry. Well, the mean is basically, this means when you see a capital sigma here in mathematics, that means summation. And so what we're asking you to do is to add up all of the objects in the population or the sample, and then divide them by the sample size. And n is going to be pretty standardly used for sample size. So here's our first tricky thing, is we're going to have different symbols depending on what kind of mean it is. If it is a population mean, like the SAT score, we will use mu. Remember, that was mu. But if we are representing a sample mean, we will use this symbol, which you say as x bar. And so this, you'd read this as x bar. But we all know how to find an average. You add up and you divide by the number of things. This is just the formal formula for that. Listen to the alliteration. The English teachers would be so proud. Mode is just the observation that occurs most often. And it's really not, we're not going to use it a whole lot, except for in very large samples, we'll talk about the peak of a frequency diagram being the mode, and that's where we get the unimodal and bimodal. Because if you look at a frequency diagram, we have something like that, then, you know, this is bimodal, where on the other hand, this is unimodal. And so that's what we'll be talking about is the most common. In the data set. So what do you use? We got 3 measures of tensile tendency, and we're going to use median and mean a lot. We'll use them a lot. And so basically, in a skewed distribution, if the distribution is strongly right skewed or strongly left skewed, you're going to want to use the median if the data is strongly skewed. And you'll see this. I've told you early on that most economic data is right skewed. And so you'll see in the news, they never report average home price or average salary. They'll report median home price or median household wealth or median. And they use median a lot in economics because that data is very skewed. In non-skewed data, if the data is symmetric, then we can use the mean because that's really telling us about the center. And we talked about that last class when we found the average, and we said, is the average indicative of the center? In a skewed distribution, in a strongly skewed distribution, the mean is not in the center. And we'll get into that a lot more in Unit 2 as well. So remember when we described the distribution, we're going to use the acronym SUCS. And it was shape, center, unusual values, spread. And a bunch of people have been asking how to describe spread. And I said, well, we'll get there. And so our first measure of spread is range. Whoops, I don't know what happened there with that drawing. Is range. And range is pretty simple. To find range, you just do the maximum value minus the minimum value. Excuse me. So that's range. We're not going to use range. Instead, we're going to use this, which is known as the IQR. And the IQR stands for interquartile range. And so if you remember, I think in Algebra 1, you were asked to find the first and third quartiles. And if you don't remember, you find the quartiles just like you found the median. You put everything in, all your data in, you find the middle. And then if you find the middles between that, that's quartile 1, and that's quartile 3. And we're going to learn how to have technology do this, a lot of this for us in class. But so the interquartile range is just Q3 minus Q1. But just like the median was the 50th percentile, this is the 75th percentile, and this is the 25th percentile. And so the IQR represents the distance for the middle 50% of our data. And so here is, this is a picture of the 2008 Olympics team, but this is the weight of the men's team. So we have to cross out all the ladies. Sorry, Sarah. Sorry, Michelle. Sorry, Megan. All these people. Sorry, Ellie. Sorry, Margot. Sorry, Caitlin. Actually, I don't think that's Caitlin Snyder. So we're just going to deal with the guys. Oh, oops, missed one. And this is all the men on the 2008 Olympics squad. If you look carefully, you'll see here, if you watch The Social Network, you'll notice that these guys look the same, and that's because those are the Winklevoss twins, who are the people that sued Zuckerberg saying that they made Facebook. Watch the movie. So how do we find the median, the first quartile, the third quartile, and the IQR? All right, so how many? So we got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25. So that's 25. So what we would do in order to find the median is, so there's 25 data points. So the 13th data point, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Right there, that's the median. So then, in order to find the quartiles, we're going to go halfway in between this value and this value. And so that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So it's actually, I'm sorry, between here and here. And so that's 12, so we have to go 6 in. 1, 2, 3, 4, 5, 6. And we have to average those two, and we get 187.5 to get the first quartile. And the third quartile, we do the same thing, and we'd average these, and we get 212.5. So the IQR then is, this is Q1, this is the median, and this is Q3. So the IQR is quartile 3 minus quartile 1. And so my IQR is 25, and we always put in units, and that's not lbs, it's pounds, right? 25 pounds. So and that's our measure of how spread out the data is. 25 pounds is how spread out the middle 50% is. 25 pounds encompasses the middle 25%, I'm sorry, the middle 50% of the data. Now, early on, I was telling you, we talked about outliers in the book, but we didn't define them. And I said we'd come up with a very, very specific definition of an outlier. And the specific definition of an outlier is any value that is more 1.5 times the IQR above Q1 or Q3. So pay attention, because they will ask this on the AP exam. It's going to ask you, are there any outliers? Right? It's either going to come up as a multiple choice question, but more often than not, it'll come up in an FRQ. And it's an easy problem to do. So the question is this value here, this 121-pound guy, is that an outlier? And so what we would do is we would look at the quartile 1, we said was 187.5. So any value that is less than 187.5 minus 1.5 times the IQR is going to be considered an outlier, or any point that is below 150 pounds is an outlier. Also, any value that is above the third quartile plus 1.5 times the IQR. So in this case, 212.5 plus 1.5 times 25 is going to be any value above 250 is an outlier. Now, there are no rowers above 250 pounds. Our heaviest guy is 229. But any value below 150 is an outlier. And so this guy, who is the coxswain, the little guy that sits in the back of the 8, is an outlier. And so that's going to be our formal definition. So in order to do and just find an outlier, you're going to have to find the IQR. If you ever hear the term the 5-number summary, the 5-number summary, that should be 0.5, anyway, is the, if you ever see 5-number summary, they're asking for the min, the first quartile, the median, the third quartile, and the max. And a lot of times they'll give it to you. They'll be like, here's the 5-number summary. And this is basically telling you the data, basically. You got the minimum value, you got the maximum value, you got the middle value, and you even have the quartiles. And we're going to do box plots a little bit differently than you did them before. Because when you were in Algebra 1, you draw a line at 121, you draw a line at 187.5, a line at 205, a line at 117.5, and a line at 229, and you do your box plot. And everybody should have done that in Algebra 1. And even pre-algebra. But in AP Stats, we are not going to include outliers in our box plots. So if we go back to our data set, instead of ending at the minimum if it's an outlier, we're going to end at the next lowest point that is not an outlier. In this case, 154. And then we will put a star, right, like this, to represent the outlier. And so this is what we see here is this is our box plot, and the outlier is part of the data set, but we're going to mark it out with a star. And so what we'll be doing in class next time is practicing this and using technology, mainly our TI-84s, to create both 5-number summaries real quick and to create box plots.